All right, this is the last video for Unit 2. We've been looking at variation. The overall unit is free fall, and we're speaking about acceleration. So on page 9, using the formula for the distance an object travels when accelerating uniformly from rest, which is distance equals 1/2 times the acceleration times the square of the time. If acceleration A is constant, then we have this relationship, distance equals constant times the square of the time. We say that distance varies directly as the square of the time. This means that as the time doubles, d is multiplied by 4. When time triples, distance is multiplied by 9. If time is cut in half, distance is 1/4 as great. Let's see if that's true with a t-table of values for free fall starting from rest. Times velocity's distance. So the velocity at 0 seconds is 0 meters per second because it is a dropped object. After 1 second, its velocity is -10 meters per second. The distance that it travels, based on the formula distance equals 1/2 times the acceleration times the square of the time, (1/2) times the acceleration is -10, and the time here is 1. Don't forget to square the distance. And we have -5 meters. For the sake of our table, we're going to stick with, we've already written the formula, so let's just go ahead and fill in the numbers here. Distance equals 1/2. Acceleration of gravity is still -10. This time we are at 2 seconds, and the distance here is -20 meters. Velocity at 2 seconds was -20 meters per second. Velocity after 3 seconds, -30 meters per second. And the distance here, 1/2 times acceleration of gravity is still -10 times 3 seconds squared. The distance traveled is -45 meters. After 4 seconds, the velocity, -40 meters per second. Distance, using our formula, 1/2, acceleration of gravity is 10, 4 seconds squared. We find that the distance is 80 meters. And after 5 seconds, it's traveling at -50 meters per second. Distance is 1/2 times the acceleration, -10, times 5 seconds. And we find that it has fallen 125 meters. So we find that as time doubles, so let's say from 1 to 2, the distance is 4 times as great. From 2 to 4, same idea. 1 to -80, 4 times as great. As time triples, let's look at 1 and 3. The distance is multiplied by 9. It is 9 times as great. Knowing this relationship can help us draw a strobe photo for uniform acceleration. Just use the numbers known as the perfect squares. A couple of misconceptions among physics students. As soon as they learn that acceleration of gravity equals negative 10 meters per second squared, one of those involves the distance. When an object is dropped from rest, free fall, its velocity after 1 second is negative 10 meters per second. And the distance it has fallen after 1 second is negative 5 meters. It does not fall 10 meters in the first second. So we have 1/2 times negative 10 times 1 squared, negative 5 meters. The second misconception involves the acceleration of an object that is thrown vertically. So give the values of velocity and acceleration at each point on an object thrown vertically with an initial velocity of 50 meters per second. So here we have, this represents a ball thrown vertically. Now, this one sort of follows a parabolic shape just so we can separate it out, but imagine that this ball is really thrown straight up and then falls straight back down. So we're going to start here. We're going to call this point time of 0 seconds. The velocity at this point, we were told that it was thrown vertically at 50 meters per second. So the velocity is positive 50 meters per second. The acceleration here is the acceleration due to gravity, negative 10 meters per second squared. This next point is time of 1 second. The velocity here is 40 meters per second. The velocity will decrease by 10 meters per second every second as we go up. And the acceleration here at this point is still negative 10 meters per second squared. Here we have time equals 2 seconds. The velocity has decreased by 10 meters per second. We are now at positive 30 meters per second, and the acceleration due to gravity is still negative 10 meters per second squared. Here we have time equals 3 seconds. The velocity is 10 meters per second less, 20 meters per second, and the acceleration due to gravity, negative 10 meters per second squared. At time equals 4 seconds, this point here, velocity equals 10 meters per second. Acceleration is negative 10 meters per second squared. You've got more room on your paper than I have on the screen here. So off to the side, I'm going to do it over here. Time equals 5 seconds. That's this point. Velocity equals 0 meters per second. Remember that special rule where we could treat a object starting at the top like a dropped object. This is why the velocity is 0 meters per second. And the acceleration at this point is negative 10 meters per second squared. Next point, time 6 seconds. Velocity now, remember our velocity is increasing by negative 10 meters per second squared every second. So we went to 0, now we have negative 10 meters per second. The acceleration is negative 10 meters per second squared. At our next point, time of 7 seconds, the velocity is now negative 20 meters per second. Acceleration is negative 10 meters per second squared. At 8 seconds, the velocity is now negative 30 meters per second. The acceleration, negative 10. Time equals 9 seconds. The velocity is negative 40 meters per second. Acceleration, negative 10. Time is 10 seconds. Velocity equals negative 50 meters per second. And the acceleration, still negative 10 meters per second squared.